Question number 42 combines conservation of momentum and projectile motion. And in fact, what we're going to do, we're going to kind of solve it back. So if we're going by the data, we have a bullet that embeds itself in a block M, which is much more massive than it is, but we still have to account for the mass of the bullet when it's inside the block. After the bullet embeds itself in the block falls off, and as you can see, it acts as a projectile that was launched horizontally because the initial velocity of block plus the bullet as it starts moving off the table is horizontal. We know the distance d, which is the change in x for our horizontal, which will be using these data or these symbols. We would say d equals vx times change in t. Now change in t we can find from the fact that when it is launched off horizontally and falls through 1 meter, as they tell us that this height is 1 meter, I can say that Vy initial equals 0, therefore change in y, which is 1 meter, will be equal to 1/2 gt squared, from where t is going to be a root of 2 change in y over g. So that this time will then go into the formula for velocity. So it's going to land right here. And d is given, and we're looking actually for vx. So vx from there is going to be our distance, which is given to us as 2 meters, divided by, and then you're going to have the root of 2y and the root of g upstairs, because we are dividing by a fraction. How do I connect this v that I find right here to the initial speed of the bullet? That is where conservation of momentum comes in. So for conservation of momentum, I would say that m of the bullet, the little m, times v initial, which is I'm ultimately after, the question is the v initial, will be equal to mass of the bullet plus mass of the block times that vx that we found. So then my v initial, which I'm after, would be equal to little mass plus big mass over little mass, and then vx is d root of g over of 2 change in y.